How did Johannes Kepler become interested in astronomy, and what inspired him to pursue it as a career? Johannes Kepler's interest in astronomy was sparked at a young age when he witnessed a lunar eclipse at the age of 6. This experience fascinated him and sparked a lifelong interest in the cosmos. As a young man, Kepler studied at the University of Tübingen, where he was introduced to the work of Nicholas Copernicus, who proposed a heliocentric model of the solar system in which the Sun, not the Earth, was at the center. This idea captured Kepler's imagination and inspired him to pursue astronomy as a career. After completing his studies, Kepler became an assistant to the astronomer Tycho Brahe, who had made detailed observations of the planets but was unable to make sense of them. Kepler was tasked with analyzing Brahe's observations, and through his work, he became convinced that the heliocentric model was correct. This led him to develop his 3 laws of planetary motion, which revolutionized our understanding of the solar system and laid the foundation for modern astronomy. What were some of the key contributions that Kepler made to our understanding of the solar system and the laws of planetary motion? Johannes Kepler made several key contributions to our understanding of the solar system and the laws of planetary motion, including 1. Kepler's first law of planetary motion. Kepler discovered that the orbits of the planets are not circular, but rather elliptical, with the Sun at one of the foci of the ellipse. This means that the distance between a planet and the Sun varies throughout its orbit, and the planet moves faster when it is closer to the Sun and slower when it is farther away. 2. Kepler's second law of planetary motion. Kepler's second law states that a planet sweeps out equal areas in equal times. This means that a planet moves faster when it is closer to the Sun and slower when it is farther away, in order to maintain this balance. 3. Kepler's third law of planetary motion. Kepler's third law establishes a mathematical relationship between the distance of a planet from the Sun and its orbital period. The law states that the square of a planet's orbital period is proportional to the cube of its distance from the Sun. 4. Kepler's work on the motion of Mars. Kepler's observations of the planet Mars allowed him to develop his laws of planetary motion, but they also revealed discrepancies in the position of Mars predicted by the heliocentric model. Kepler eventually realized that these discrepancies were caused by the fact that the planets move in elliptical orbits rather than circular ones. 5. Kepler's work on optics. Kepler's work on optics and vision led him to develop a theory of how the eye works, and he was also able to explain phenomena such as the formation of images in a telescope and the colors of the rainbow. Overall, Kepler's work on planetary motion and optics revolutionized our understanding of the universe and paved the way for the development of modern astronomy and physics. Kepler is often described as one of the most important figures in the scientific revolution. Why do you think his work was so influential, and what impact did it have on later scientific developments? Kepler is often considered one of the most important figures in the scientific revolution because his work fundamentally transformed our understanding of the universe and paved the way for the development of modern astronomy and physics. There are several reasons why his work was so influential. 1. Kepler's laws of planetary motion represented a significant departure from the earlier Ptolemaic model, which had placed the Earth at the center of the universe. Kepler's work established the heliocentric model, in which the Sun is at the center of the solar system, and provided a more accurate description of the motions of the planets. 2. Kepler's laws of planetary motion were based on empirical observations rather than theoretical assumptions, which was a departure from earlier methods of scientific inquiry. This approach was more in line with the principles of the scientific revolution, which emphasized the importance of empirical evidence and experimentation. 3. Kepler's work had a significant impact on the development of physics, as his laws of planetary motion provided a mathematical framework for understanding the motion of celestial bodies. This framework was later extended to other areas of physics, such as the study of gravitation. 4. Kepler's work on optics also had a significant impact on later scientific developments, as his theories of how light is refracted and reflected helped to explain a wide range of phenomena, from the formation of images in telescopes to the colors of the rainbow. Overall, Kepler's work had a profound impact on the development of science and our understanding of the universe. His approach to scientific inquiry, which emphasized empirical observation and mathematical analysis, laid the foundation for later scientific developments, and his contributions to the study of astronomy and optics continue to influence scientists and thinkers today. Kepler was also a deeply religious person, and he believed that his scientific work was a way of understanding God's creation. How did his religious beliefs inform his scientific work, and how did he reconcile these two seemingly conflicting worldviews? Kepler's deep religious faith was an important part of his life, and he believed that his scientific work was a way of understanding God's creation. He saw no conflict between his scientific pursuits and his religious beliefs, and he believed that the natural world was a reflection of God's design. Kepler's religious beliefs influenced his scientific work in several ways. First, he believed that the universe was orderly and harmonious, which led him to seek mathematical laws that would explain the motions of the planets. He believed that these laws were a manifestation of God's divine order, and he saw his work as a way of understanding and appreciating God's creation. Second, Kepler believed that the study of astronomy was a way of glorifying God, and he saw his work as a form of worship. He believed that by studying the heavens, he could gain a deeper understanding of God's wisdom and power. Finally, Kepler believed that science and religion were not mutually exclusive, and that they could be reconciled through a common pursuit of truth. He saw science and religion as complementary ways of understanding the world, and he believed that both were necessary for a complete understanding of the natural world. In summary, Kepler's deep religious faith informed his scientific work in a number of ways, and he saw no conflict between his scientific pursuits and his religious beliefs. He believed that science and religion were complementary ways of understanding the world, and that both were necessary for a complete understanding of God's creation. Kepler's life was marked by many personal and professional challenges, including the death of several family members and periods of political turmoil. How did these challenges shape his work, and what lessons can we learn from his perseverance and resilience? Kepler faced many personal and professional challenges throughout his life, including the death of several family members and periods of political turmoil. These challenges had a significant impact on his work and shaped his approach to scientific inquiry. One of the most important lessons we can learn from Kepler's life is his perseverance and resilience in the face of adversity. Despite the many challenges he faced, Kepler remained committed to his work and continued to pursue his scientific goals. He was able to find meaning and purpose in his work, even in the midst of personal tragedy and political turmoil. Kepler's challenges also shaped his work in more concrete ways. For example, during periods of political instability, Kepler was forced to move from place to place, which made it difficult for him to carry out his research. This led him to develop new methods for analyzing data remotely, which were later used by other astronomers. In addition, Kepler's personal struggles led him to develop a more holistic approach to science, which took into account the emotional and spiritual dimensions of human experience. He believed that science could help to illuminate the mysteries of the natural world, but he also saw it as a way of understanding ourselves and our place in the universe. Overall, Kepler's life was marked by many challenges, but he was able to find meaning and purpose in his work, and his resilience and perseverance continue to inspire us today. His approach to scientific inquiry, which emphasized the importance of perseverance, resilience, and a holistic understanding of the natural world, can serve as a valuable lesson for all of us. Kepler was known for his strong opinions and his willingness to challenge established scientific and religious authorities. How did this affect his relationships with other scientists and scholars of his time, and what can we learn from his willingness to question conventional wisdom? Kepler's willingness to challenge established scientific and religious authorities had a significant impact on his relationships with other scientists and scholars of his time. On one hand, his independent thinking and willingness to question conventional wisdom made him a respected figure among some of his colleagues. On the other hand, his strong opinions and willingness to challenge established beliefs also made him a controversial figure who sometimes faced opposition and criticism from other scientists and scholars. One example of Kepler's willingness to challenge established beliefs is his rejection of the Aristotelian idea that the motions of the planets were caused by uniform circular motion. Kepler's observations showed that the planets moved in elliptical orbits, and he was willing to challenge the established view that uniform circular motion was the only possible explanation for their motions. Kepler's willingness to challenge established beliefs can serve as a valuable lesson for us today. It reminds us of the importance of independent thinking and critical inquiry, and it encourages us to question conventional wisdom and challenge established beliefs when we encounter new evidence or information. At the same time, Kepler's example also reminds us of the importance of open-mindedness and collaboration, as he was willing to work with other scientists and scholars in order to advance our understanding of the natural world. Kepler's work had a significant impact on the development of astronomy and physics, but it also influenced other fields, such as philosophy, mathematics, and even literature. How did his ideas and discoveries influence these other disciplines, and what can we learn from the interdisciplinary nature of his work? Kepler's work had a profound impact on a wide range of disciplines beyond astronomy and physics. Here are some examples. 1. Mathematics. Kepler's work on planetary motion required him to develop new mathematical tools and techniques, such as his use of ellipses to describe the orbits of the planets. These innovations had a significant impact on the development of calculus and other areas of mathematics. 2. Philosophy. Kepler's work on the nature of the universe and the laws of planetary motion had a significant impact on the development of philosophy, particularly the philosophy of science. His emphasis on empirical observation and mathematical analysis helped to establish a more rigorous and systematic approach to scientific inquiry. 3. Literature. Kepler's ideas about the universe and the relationship between science and religion influenced many writers and artists of his time, and continue to inspire writers and artists today. For example, his idea of the harmony of the spheres inspired the poet John Milton, who wrote about it in his famous work Paradise Lost. 4. Theology. Kepler's religious beliefs and his view of science as a way of understanding God's creation had a significant impact on the development of theology. His work helped to reconcile science and religion, and his approach to scientific inquiry influenced many theologians of his time. The interdisciplinary nature of Kepler's work reminds us of the interconnectedness of different fields of study, and the importance of collaboration and communication across disciplines. His innovations in astronomy and mathematics, for example, were closely intertwined with his philosophical and religious beliefs, and his ideas had a significant impact on the development of many other fields. This interdisciplinary approach can help us to better understand complex phenomena and to find new solutions to important problems. Kepler was also a prolific writer, and he produced numerous works on a wide range of topics, including astronomy, astrology, theology, and mathematics. What can we learn from his approach to writing and communication, and how did he use his writing to advance his scientific and philosophical ideas? Kepler's approach to writing and communication was shaped by his deep commitment to understanding the natural world and his belief in the importance of sharing his discoveries with others. He saw writing as a way of communicating his ideas to a wider audience. Kepler's legacy continues to inspire scientists and thinkers today, nearly 400 years after his death. What do you think is the most important lesson that we can learn from his life and work, and how can we apply these lessons to our own lives and careers? Kepler's legacy continues to inspire us today because he embodied the spirit of scientific inquiry, independent thinking, and perseverance. He challenged established beliefs and pursued his scientific goals with a sense of purpose and dedication, even in the face of personal and professional challenges. One of the most important lessons we can learn from Kepler's life and work is the importance of curiosity and the pursuit of knowledge. He was driven by a deep curiosity about the natural world, and he was willing to follow his intuition and explore new ideas, even when they challenged established beliefs. Another lesson we can learn from Kepler is the importance of resilience and perseverance in the face of adversity. Kepler faced many challenges throughout his life, including personal tragedies, political turmoil, and scientific opposition, but he never gave up on his goals or his belief in the power of science to reveal the mysteries of the natural world. Finally, Kepler's legacy reminds us of the importance of interdisciplinary thinking and collaboration. His work bridged the gap between different fields of knowledge, and he saw science as a way of understanding the natural world in its entirety. By embracing interdisciplinary thinking and collaborating with others, we can gain a deeper understanding of complex problems and find new solutions to important challenges. In summary, the most important lesson we can learn from Kepler's life and work is the importance of curiosity, perseverance, and interdisciplinary thinking. By following in Kepler's footsteps and pursuing our goals with purpose and dedication, we can make important contributions to science and society, and we can continue to push the boundaries of our understanding of the natural world. If you could ask Kepler one question, what would it be, and why? If I could ask Kepler one question, it would be: what advice would you give to young scientists and thinkers today who are seeking to make important contributions to science and society? I would ask this question because I believe that Kepler's life and work can serve as a valuable source of inspiration and guidance for young scientists and thinkers today. His commitment to scientific inquiry, independent thinking, and interdisciplinary collaboration can provide a roadmap for those who are seeking to make important contributions to science and society. Kepler's answer to this question could provide insights into his personal philosophy and approach to scientific inquiry, as well as practical advice for young scientists who are seeking to follow in his footsteps. His response could also inspire us to continue pushing the boundaries of our understanding of the natural world and to embrace new ideas and approaches in the pursuit of knowledge. Kepler's work on planetary motion was based on observations of the planets made by Tycho Brahe. How did Kepler and Brahe's collaboration influence each other's work, and what lessons can we learn from their partnership? Kepler and Brahe's collaboration was a crucial aspect of Kepler's work on planetary motion, and it had a significant impact on both of their scientific careers. Brahe's observations of the planets provided Kepler with the data he needed to develop his laws of planetary motion, while Kepler's mathematical and analytical skills helped Brahe to analyze and interpret his observations. One of the key lessons we can learn from Kepler and Brahe's partnership is the importance of collaboration and interdisciplinary thinking. Kepler and Brahe came from different backgrounds and had different areas of expertise, but they were able to work together effectively by combining their strengths and sharing their knowledge. Another important lesson we can learn from their partnership is the importance of empirical observation and data-driven analysis. Brahe's meticulous observations of the planets provided Kepler with the data he needed to develop his laws of planetary motion, and Kepler's mathematical analysis helped to make sense of the complex patterns and motions of the planets. Finally, Kepler and Brahe's partnership reminds us of the importance of mentorship and the passing down of knowledge from one generation to the next. Brahe served as a mentor to Kepler, providing him with the guidance and support he needed to develop his ideas and advance his career. In summary, Kepler and Brahe's partnership was a key aspect of Kepler's work on planetary motion, and it had a significant impact on both of their scientific careers. Their collaboration teaches us the importance of interdisciplinary thinking, empirical observation, and mentorship in the pursuit of scientific knowledge. Kepler's three laws of planetary motion are often described as some of the most elegant and simple scientific theories ever formulated. What do you think makes them so elegant, and how did Kepler arrive at these laws? Kepler's three laws of planetary motion are considered elegant and simple because they describe the complex motions of the planets in a way that is both easy to understand and mathematically precise. Here are some reasons why these laws are considered elegant. 1. The first law states that the planets move in elliptical orbits around the Sun, with the Sun at one of the foci of the ellipse. This law is elegant because it describes the shape of the orbits in a simple and intuitive way, and it allows for the precise calculation of the planet's position at any given time. 2. The second law states that the line connecting a planet to the Sun sweeps out equal areas in equal times. This law is elegant because it describes the speed of the planet's motion in a way that is mathematically precise, and it allows for the prediction of the planet's position at any given time. 3. The third law states that the square of the period of a planet's orbit is proportional to the cube of its average distance from the Sun. This law is elegant because it describes the relationship between a planet's orbital period and its distance from the Sun in a simple and precise way, and it allows for the prediction of the orbital periods of other planets. Kepler arrived at these laws through a combination of careful observation and mathematical analysis. He spent many years studying the motions of the planets and gathering data on their positions and velocities, and he used this data to develop his laws of planetary motion. His laws were based on a combination of empirical observation and mathematical analysis, and they represented a major breakthrough in our understanding of the natural world. In summary, Kepler's laws of planetary motion are considered elegant and simple because they describe the complex motions of the planets in a way that is both easy to understand and mathematically precise. Kepler arrived at these laws through a combination of careful observation and mathematical analysis, and they represent a major breakthrough in our understanding of the natural world. Kepler's work on optics and vision was also groundbreaking, and he was one of the first scientists to develop a theory of how the eye works. How did his work on optics inform his understanding of astronomy, and what impact did it have on the development of modern ophthalmology? Kepler's work on optics and vision was an important part of his scientific career, and it had a significant impact on both his understanding of astronomy and the development of modern ophthalmology. One of the key ways in which Kepler's work on optics informed his understanding of astronomy was by providing him with a better understanding of the nature of light and how it interacts with the human eye. Kepler's work on the optics of the eye helped him to develop a better understanding of how we perceive the world around us, and he used this knowledge to develop new methods for observing and studying the planets. For example, Kepler's work on the optics of the eye led him to develop a new type of telescope, known as the Kepler ion telescope, which uses two lenses to produce a clear and magnified image. This type of telescope was a major improvement over earlier telescopes, which suffered from distortions and aberrations that made it difficult to observe the planets and other celestial objects. In addition to its impact on astronomy, Kepler's work on optics had a significant impact on the development of modern ophthalmology. His understanding of the structure and function of the eye helped to lay the foundation for modern ophthalmology, and his work on the optics of the eye paved the way for new treatments and surgical procedures. Overall, Kepler's work on optics and vision had a significant impact on both his understanding of astronomy and the development of modern ophthalmology. His innovative approaches to studying light and its interactions with the human eye helped to revolutionize our understanding of the natural world and pave the way for new discoveries and advancements in science and medicine. Kepler was a master of mathematics and geometry, and he used these skills to develop new methods for calculating the positions of the planets. How did he use mathematics to advance his scientific theories, and what can we learn from his approach to problem solving? Kepler's mastery of mathematics and geometry was a crucial aspect of his scientific work, and he used these skills to develop new methods for calculating the positions of the planets and advancing his scientific theories. Here are some ways in which he used mathematics to advance his work. 1. Kepler used mathematical analysis to interpret his observations of the planets and develop his laws of planetary motion. He used a combination of empirical observation and mathematical analysis to derive his laws, which represented a major breakthrough in our understanding of the natural world. 2. Kepler used geometry to model the orbits of the planets and develop new methods for calculating their positions. His work on the geometry of the solar system paved the way for new discoveries and advancements in astronomy and mathematics. 3. Kepler also used mathematics to develop new theories and solve complex problems in other areas of science and philosophy. For example, his work on the optics of the eye involved complex mathematical calculations and led to new discoveries in the field of ophthalmology. One of the key lessons we can learn from Kepler's approach to problem solving is the importance of combining empirical observation with mathematical analysis. Kepler's work on the orbits of the planets was based on a combination of careful observation and mathematical analysis, and he used this approach to develop new theories and solve complex problems in a wide range of fields. Another important lesson we can learn from Kepler's approach to problem solving is the importance of perseverance and independent thinking. Kepler faced many challenges throughout his career, including scientific opposition, political turmoil, and personal tragedies, but he never gave up on his goals or his belief in the power of science to reveal the mysteries of the natural world. In summary, Kepler's mastery of mathematics and geometry was a crucial aspect of his scientific work, and he used these skills to develop new methods for calculating the positions of the planets and advancing his scientific theories. His approach to problem solving teaches us the importance of combining empirical observation with mathematical analysis, as well as the importance of perseverance and independent thinking in the pursuit of scientific knowledge. Kepler's work was not always well received during his lifetime, and he faced criticism and opposition from many quarters. How did he respond to these challenges, and what can we learn from his resilience in the face of adversity? Kepler faced numerous challenges and obstacles during his lifetime, including political turmoil, personal tragedy, and scientific opposition. Despite these difficulties, he remained dedicated to his work and never gave up on his goals or his belief in the power of science to reveal the mysteries of the natural world. Here are some ways in which Kepler responded to these challenges. 1. Kepler was committed to independent thinking and refused to be swayed by the opinions of others. He was willing to challenge established beliefs and pursue his scientific goals with a sense of purpose and dedication, even in the face of criticism and opposition. 2. Kepler was a resilient and determined individual who was able to overcome personal tragedies and setbacks. For example, he lost his first wife and several children to illness, but he continued to pursue his work with the same level of commitment and dedication. 3. Kepler was also a patient and meticulous scientist who was willing to take the time to carefully observe and analyze the natural world. He understood that scientific progress often requires patience and persistence, and he was willing to put in the hard work necessary to achieve his goals. Overall, Kepler's resilience in the face of adversity teaches us the importance of perseverance, dedication, and independent thinking in the pursuit of scientific knowledge. Despite facing numerous challenges and setbacks, Kepler remained committed to his work and his belief in the power of science to reveal the mysteries of the natural world. His example reminds us that scientific progress often requires patience, persistence, and a willingness to challenge established beliefs and pursue new ideas.